Hello there guys, welcome back to today's video. Make sure that you look at the video, you focus on the question that you got wrong, and then you pop up on your work, you add the full corrections in, the full working out in, and make sure that you are indeed awake. Okay, now this paper is multiple choice, but we're here to know the physics, so we're here to know the physics of it, so we're here to know the full physics. Okay, so why is the answer A, why is the answer B, why is the answer C, and why is the answer D in this case? Yeah, so we want to know why is this particular case. Alright, now let's crack on. The first question we have is about wave. Oops, so this is the question. Okay, so I'm just taking a snapshot of those questions as we go along. Alright, now first question is, we have a sound wave that is traveling. We know the frequency of the sound wave, and we know we know f, we know the speed. Now the question says 2 points are this much apart. So what's the phase difference? Now first of all, I want to know the wavelength. So therefore we know that the equation, so start here, is the speed of the wave is frequency times wavelength. So I'm looking for wavelength, so therefore wavelength is equal to wave speed over frequency. Okay, now let's put the numbers in. 0.8 meters. So the wavelength is 0.8 meters. Now what I want to know is, I want to know how much is that of it. How much is that of it? Because what we have is, we know that, so far we know that 0.8 meters is equivalent to one wavelength. Now I want to know 0.2 meters, how much is that in terms of wavelength? So therefore it's going to be what? So it's going to be 0.2 divided by this one, and this will give me an answer of, okay, so let me just do it let me just do it this way so we don't get confused. So here we go. So I want to know how much is that of the wavelength. So therefore, so we know that 0.8 meters is one wavelength, so therefore 0.2 meters, how much is that of the wavelength? So therefore it's going to be 0.2 divided by 0.8, and this will give me an answer of a quarter. So this is a quarter of the wavelength. So therefore, if I have to draw the wave, then the wave is going to look like this one here. So let me draw a wave. The wave is going to go up, down, and up here. So a quarter wave is here. So a quarter wave. So this is a quarter of the wave. So therefore, what we have? So 2 points. Direction of travel is this one apart. So therefore, we've got 2 points. So 1 point is here, and 1 point is, let's say, here maybe. So this point here is a quarter of the wavelength. Now a quarter of the wavelength, so the options given to us are in radian. So what do we know? We know that this is 0, so we know that this is pi, this is 2 pi. So therefore this here has to be pi over 2. So therefore the answer is going to be B in this particular case. And here is the working out why. Good. Now question 2. So this is a very good question. So something we've done before, if you remember, ages ago. Now, you want to know what is going to happen to where P is going to be, where Q is going to be in the future. So what you want to do here, so I'm going to do this one straight away on the question itself, because this is a nice and easy question. So you want to do is, you want to move the wave in the future. So move the wave in the future. So shift the wave a little bit in the future. So let me shift the wave. So therefore, so the wave shifted. So now let me do this wave here to start here. Yeah, she shifted. Let me just shifted it here. So therefore, I shifted it here. So the wave has shifted in this case. Yeah. So therefore, so what I'm drawing now, I'm drawing the wave shifted. Doesn't matter how much you shifted it. So I shifted it in the future a little bit. Okay. I shifted it a little bit in the future in this particular case. Okay. Okay. So the question is gonna see is gonna what's gonna happen to point Q. Okay, let me see how I should do it properly. So this goes here. This okay. Let me just do it properly so you can see it. Let me zoom in again. Let me see if I can zoom in. Oh yeah, I can zoom in. Okay, so this is the point. Let me just put the point properly so you can see where the wave is touching the midpoint. So I shifted it here, so in the middle point. So here, so therefore this would be here. So this would be go up, go down here. So here we go. Down here, down here, up, down here. Okay, here we go. So that should be enough shifting. Now let's take what happened to P. Now P, what happened? So P has gone up now because P, look, initially P was down, P was here, and then now the wave has gone up. So it's gone up. Now Q was here, and what happened? It went down. So you can clearly see that as the wave's moving, the particles only oscillate up and down. The particles only oscillate up and down because this is a transverse wave. So therefore, the answer is the following. So therefore, P is going to go up and Q is going to go down. So the answer in this particular case is going to be C. Again, so make sure when you're marking your work, you draw the wave in the future. Okay, so you move the wave in the future in this particular case. Okay. Okay, now with a question like this, you want to be careful not to shift the wave too much, yeah, because the wave is gradually moving over a certain amount of distance. So that's why I shifted it not too much, just a little bit here. Okay, all right, cool. Now let's go on to the next question, question 3. Okay, now the question 3 is about intensity. Intensity. All right, let's do this. So we have a source, and this source is emitting sound in all direction. Okay, and we are someone standing here. So this person is standing 10 meters away. Now, if you remember, the equation for intensity is equal to power over the surface area. Sorry, surface area. Because the sound is being emitted in all directions. So all 360 direction. Okay, that's sound being directed. Okay. Now this cross-sectional area, so this is power is power over 4 pi r squared because that is in 3 dimensions. So this is a sphere. Okay. Now we have no idea what power is, but we do know that the sound has to be as loud as before. Okay, as loud as before. As loud as before. Okay. Okay. Now what we want to know is we want to know the relationship between I and R. Okay, so the relationship it is an inverse square law. Alright, so you can see as the intensity is going up, then the radius is squaring down in this particular case. Okay, that's why the further you go, then the intensity gets less and less, but square time. Okay, now let's take a look. Initially, so at the start, so let me just remove this. So I'm gonna say, so at the start, so the intensity is directly proportional to 1 over r. Now r is 10, so that's 10 squared, so therefore it's going to be proportional to 1 over 100. Okay. Now later on, so let me just put later on. So later on, what happened is the intensity has gone down by a half. So therefore we know that the relationship is this one. Okay. Now what we've done is we've halved the intensity. Now if we're halving the intensity, what's going to happen to the radius? Okay, the radius, so radius is squared, yeah. So the radius is going to go, so since it is inversely, so if the intensity is dropping, it means that the radius is going to go up by a factor of 2 because 2, yes, but since we square, it's going to go up by a factor of 2 squared. So therefore what we're going to have, I divided by 2 because we're halving it, and that is proportional to 1 over. So since it is squared, so it is inversely proportional, so it got by 2 but squared, so therefore that's 4, and then the r stayed the r in this particular case. Okay, Now let's simplify this. So therefore, proportional to the 2 goes on the other side, divided by 4 r squared, and let me just simplify this again. So this give me 1 over 2 r squared. Okay, good. Now you see that here I have I as well. So we're going to put them together. We're going to put them together. So therefore I have 100. Okay, approximately proportional, yeah, 1 over r squared. Okay, let me just check. I don't want to confuse the question. Okay, 1 over squared. So therefore, now you can see that I can easily write it as 100 is equivalent to this one here. So therefore, 100 divided by 2 is equal to r squared. So this will be 50 is equal to r. So 50 squared. Okay. Oh, sorry, I made a mistake. It's not it's not 10. It's 8 actually. Sorry, my bad. So this is 8 squared. Okay, so this will be 64. My bad, my bad. But everything is fine. Everything else fine. So 64 here, 64 here, 64 here. Okay, my bad. This is 32, 32, 32, and this give me 6.5. And this is equivalent to, so if you look at the answer, your possible answer, this will be equivalent to 4 root 2, and therefore the answer in this case is D. Okay, so this is the working out of this case. Okay, alright, next question. Let's crack on. Now, this is something that we've done already in the do now. Now, first of all, we have, so since we're dealing with light, so we know that speed of light is equal to f lambda. Now what we're going to do is we are going to work out the frequency, because we don't know the frequency. The frequency is equal to speed of light over lambda. Speed of light we know is 3 times 10 to the power 8. Now the wavelength is red light. Now this here, we've done this in the required practical, so we've done this in RP, if you remember. So required practical, so it is times 10 to the power nanometers. So it was something to the nanometers. Okay, so it was something to the nanometers. I think it was -9, isn't it? -9. It was just something to the -9. So it was like it was between 500, I think, was to 700 nanometers. So in this case, -9. Okay, -9. Okay, so this no matter which one you take, I'm going to take the extreme one. Let's say 700 power -9. Okay, and then plug this into your calculator, and this will give you an answer of 4.2, 3 power 14 hertz. Okay, and then we know that frequency is number of waves per time per second. So the question says how many number of wave we have. So the wavelength, so number of wavelengths. So if you remember, so we've got a wave. Okay, so the wavelength is actually a complete wave. So this is here is a complete wave. So therefore we're looking for that. So therefore if we arrange, so number of wave equal to frequency times the time. In this case frequency is this much, bracket, multiplied by 2.5 times 10 to the power -9. Okay, and this will give me 1.07 times 10 to the power 1, 2, 3, 4, 5, 6. Okay, so the answer is B in this particular case. Okay, all good. Alright, so let's go for this one. Now, the problem with this one is this is actually superposed. Okay, not superimposed, superposed. So you are superposing these waves together. Okay, now this one here, you can see this one in this particular case. Okay, now you can see that this one here and this one is actually twice of that. So this is positive, so this is negative. Yeah, so therefore they cancel each other out. So I'm going to give a number there. So let's say this is +1, and this looks like it is -2. Okay, so therefore you add them together. So you add them together. So amplitude. Okay, so the amplitude is going to be, the displacement is going to be, so you got +1, and so since they are antiphase with each other, we're going to take away. Okay, we're going to add, sorry. So the sum. So so superposition and the wave add up together. So they add up together. So the amplitude add up together. So therefore, it's going to be +1 plus -2. Am I doing this correctly? Okay. Oh, you can tell here. So the amplitude is y, and the other one is 2y respectively. Okay. All right. Okay. So let's do this. So let's take this one. So this is 2y. Okay, and this is y in this particular case. All right. Okay. So therefore, they are going to. So this is their antiphase. So this one here will try to cancel with this one, and then you're going to end up with just y. Okay, so you can actually do the maths. Alright, so this is y, so this is going to be, so this is, so the amplitude, that will be the amplitude, that will be minus y, this is positive 2. Okay, so minus y plus y, so this just gives you y pretty much. So you've got two options there, and then you know that for us to get antiphase, if I do the wave like this, antiphase, you can see that the wave is shifted by pi in this particular case. So the answer is going to be B here. Okay. Now what we have here, we have two slits, and we get dark fringes. So dark fringes, so we know that dark fringes, dark is equal to destructive interference. So therefore, the phase difference for that, the phase diff, is going to be pi, 3 pi, 5 pi, and so on. Okay, and remember the path difference is going to be n plus half lambda. So I just put it there so that you know as well. Okay, now this one is straightforward. Okay, so remember the equation. So we know that the equation is n lambda is equal to d sine theta for our wavelength. Okay, we want to know, so we know that second order is for x, and then third order is for y. So therefore I'm going to label this. So therefore when it is 2, so 2, this is wavelength of x. Okay, equal to d sine theta. Okay, and then when it is 3, so therefore same equation, it's going to be 3 lambda y is equal to sine d theta. Okay, now this slit distance is the same. Okay, all right, two slits, we're using the same slits. Okay, so you're using the same slits in this case, the same slits, so therefore the angles coming out doesn't matter. Okay, so therefore we are going to have, you can see that we're dividing with each other, so therefore it's going to be, so you divide them together, you're going to have so 2 sine theta divided by 3 sine theta is equal to sine theta over sine theta. So these two cancel out, so you're left with 2 third lambda y is equal to 1, and the question says what is the ratio of these two, so therefore you flip them around, so 3 over 2, so the answer is going to be 3 over 2, which is C in this particular case. Okay, alright, okay, so what we got here, fringes. Okay, now fringes, so here we go, where are we? So wavelength, blah blah, fourth pair of slits. Okay, we've got the slits. Okay, we've got the fringes here. The fringes are this apart, so let's say we've got bright spot, dark spot. Okay, so the fringes is 3 millimeter. What else do we do? The wavelength. Okay, okay, light just is used, blah blah. Okay, so we need to know the relationship between these two. So remember, so W is equal to N lambda capital D over S. Okay, now in this case, what are we doing? We want to know the relationship between W is proportional to wavelength. Okay, now what's happening to the wavelength? The wavelength, so we're using is 600 and it goes down to 300. So therefore, what we're doing is we are decreasing the wavelength by 2. So if we're decreasing the wavelength by 2, so therefore the fringes goes down by 2. So therefore the fringes goes down by 2. So the fringes were 3 millimeters, so go down by 2. So this becomes 1.5 millimeter, and the answer is B in this particular case. Okay, alright, let's go through this one here. Now, adjacent nodes, so it is a standing wave. Adjacent nodes, so nodes, we know that they are destructive indifferent. So remember, we got a fixed point here, and another fixed point at 1 point. So in this case, blah blah is produced to progressive wave, the meetup, and so on and so forth. So adjacent nodes, so it doesn't matter the wave. We don't know how many wave. It's the first harmonic. We don't care. So we got the wave. Let me just draw a wave here. Okay, all right, and then of course it's gonna reflect on itself, and it's going to interfere. Here we go. Now nodes, so where are we going to get nodes? We've got nodes here. So these are the nodes. So this is the nodes. The node is this much apart. Yeah, the node is this much apart. Okay, it could be the first harmonic, which is the entire thing. We don't know. Okay, so don't worry about it. Now what we do know is we know that the frequency is this much. That's how much the node is. We need to work out the speed in this particular case. Okay. Now the beauty with this is, I'll show you something here. So speed is equal to frequency times wavelength. We're looking for the speed. Now frequency, let's take a look. Do we know the frequency? Yes, we do know 300. We need to work out the wavelength. Now let me do the first harmonic. Let's do the first harmonic. Yeah. Now the first harmonic, it goes all the way there, gets reflected backwards. Now notice that. So this is the node, yeah, one node, two node, three nodes. So you notice that so from one node to the next node, we have, what do we have? So we have half a wavelength, yeah. Now same thing here, we have half a wavelength here. Okay, so if half a wavelength is 1.5, so wavelength half is going to 1.5. So therefore, wavelength is going to be twice. It's going to be 1.5 times 2, okay, which is 3 meters. Therefore, the wavelength is going to be 3 meters, and then we have 900 meters per second, and the answer is D. Okay, so that's how it's always good to draw these things, so you can visually see what's happening. Okay, now question 10. This is resistivity. Okay, you guys on the resistivity, so let's do equation is R is equal to resistivity times length of the wire divided by the area. Now we want to know how is linked to these things. Okay, piece of square metal, thickness, blah blah. They're made of some metal. Okay, they're made of from the same metal. So the resistivity of both of them is the same. So let's do this. So we got the first one. We got X. We got X to Y. So we got X. So Rx is equal to. So resistivity is the same. So we don't care about that. So length. What's the length of this? The length is L, so put L there. Okay, divided by the area. So what is this area of the shape here? So it is T times L, so therefore it is T times L. Okay, and therefore we're going to do the other one as well, which is Y, so which is 2L this time, yeah? So therefore it's going to be R, Y equals, again, the resistivity is the same because same material, it's going to be 2L over T times 2L. Okay, the length is 2L and it's 2L. Okay, and then you'll see that it actually come back to L over TL, which is the same. So therefore, when we do the ratio, which is this over, oops, this over this, what do we get? So Rx is L. Okay, we're going to do this properly so again there's no confusion. So this, oh my god, control myself. Okay, so Rx is L over TL divided by L over TL, so they are the same, so therefore it just is 1 over 1. So the answer is C. Okay, now 11. Okay, now what we have is we have cables. Yeah, let me just draw cables here. Cables. Okay, you know the resistor of the cable is 5. Okay, and we know that it is connected to a generator. I don't know how to draw a generator. Okay, let's do it like this. The generator. Okay, so the power there is 100 kilowatt. Voltage is 10 k volts. Okay, now how much power is dissipated in the cable? So how much power is actually being lost by the cable? That's what we want to find out. Okay, okay. Now the problem here is the power given to us is the power for the generator. So this power is for the generator. This voltage is for the generator. So you need to ask yourself, what is the thing that comes from the generator and that flows in the wire, which is current. So therefore you need to know the current produced. So therefore we have P is equal to IV. So we're going to write I is going to P over V. So therefore 100k by 10k, so this gives us 10 amps. So therefore there's 10 amps of current flowing through. So therefore power is equal to I squared R, okay, and I is 10 squared R is 5, so therefore it's going to be 500 watts. So this is how much power is actually lost by the cable. Okay, good. Okay, so let's take a look. This one is the conductivity decreases when temperature goes up. Now let's think of the wire. Now wires, they're made up of everything is, so wires is solid, okay, it's made of atoms or ions, yeah. Okay, let's do like this. Again, so when you are adding your corrections, you'll have to add the explanation as well. Okay, so let's do this. Right, solid. Okay, of course you have free electrons around, yeah, which can zoom past. Okay, now, so as temperature increases, what's going to happen? So those ions, so those metal ions, okay, equals, they're going to vibrate more, okay, because what's happening is the ions gain kinetic energy, so they start to vibrate more. Now, the question says is the conductivity is decreasing, so this means that the temperature is increasing even more. So as temperature is increasing even more, then you have vigorous vibrations. Okay, and this actually weakens the intermolecular bonds, okay, between those ions. And what's going to happen is those ions, they will start to go further from each other. Okay, because those bonds are weakening now. Those bonds are weakening. Okay. Okay, so those bonds are weakening, so they get weaker. So spaces increases, spaces increase. Okay, so you can see that the metal expands. Okay, so here's the explanation, and the option that talk about this is this one here. Okay, excellent. All right, let's crack on. This one's nice and easy question. Okay, let's take a look now. Energy. So we know that energy is equal to charge multiplied by voltage. Okay, now we've got two things here. We've got voltage across the cell. Okay, sorry, we've got energy across the load, which is this one, and energy across the whole circuit. Okay, now let's do the load first. Now the energy of the load is going to be energy is equal to charge voltage. So charge in the wire, we don't know. I just put a Q. Now the voltage across this is going to be I times R. Okay, so therefore this is going to be Q I R. Now circuit energy again, Q is equal to E is equal to Q. Now the voltage of the entire circuit is the voltage of this guy plus the voltage of this guy. Okay, which is pretty much the EMF of the cell. Okay, which is pretty much the EMF of the cell. Okay, now if you remember when you guys did EMF, so the EMF is just this little symbol here. So because we're looking for the voltage of the whole circuit, so the whole circuit combined. Okay, so the voltage of the whole circuit combined, which is the EMF, come actually from the battery itself. Okay, which I believed. Okay, so therefore we got Q. Now the EMF is going to be the voltage across the internal resistor plus the voltage across the circuit, across the load in this case. So therefore I'm going to simplify this even further. So we've got I small r plus I big R. Remember V is equal to IR. Okay, now I is the same because it's series circuit. It's a series circuit, so this one here and this one here is in series. So therefore I take I out to end up with R plus capital R, and this is energy. Okay, now we're taking the ratio again, so the ratio of the load over this one here. So we're taking the load over this one here. So it's load divided by the whole circuit energy. So therefore it's going to be Q IR divided by Q I bracket small r plus this. The Q I cancel out, so these guys cancel out. So these here cancel out. So we're left with R plus R. So let's look at the answers. So big R, small r, and so on and so forth. The answer is going to be D in this particular case. Okay. Now this one's basic property. So this is for a resistor. So remember, so this is voltage directly proportional to current. This one is for a lamp, because you can see that as voltage increases, current increases. However, it gets hot. The lamp gets hot. As the lamp gets hot, the resistance increases. That's why current plateau. And this is a diode in this case. So 14 is straightforward, yeah. So 14 we got, what was it, metal, which is at constant temperature. That's a resistor normally, so that's going to be Y. Okay, we got diode, which is X. We've got the lamp, which is Z. So the answer is going to be B for 14. Okay. Right, so where are we? So 15, okay, 15. Okay, so resistance. Resistance is V over I. Okay, now we know that voltage is coulomb. Wait, voltage is coulomb, is joules per coulomb. So yeah, so remember voltage. So we know that energy is equal to charge V. So therefore, energy over Q is voltage. So I'm going to put this in. So energy over Q divided by current. So this is energy over charge current in this particular case. What else can we? Okay, now energy is the same as work done. Work done is force times distance over charge I. Okay, right, charge we know, so times D. Charge we know, charge is current times time times current, so therefore I have force times distance. Okay, so we know that force times distance, so force is m times acceleration times d over I squared times time. I think we have pretty much done everything. Now let's do everything in units now. Unit. Okay, the unit for mass is kg. The unit for acceleration is meter per second squared. The unit for so multiply. Okay, put the bracket. Okay, let me use a bracket there because it's very okay. Kilogram meters per second squared bracket, and then meter for the distance divided by amps squared, and then time, which is in second. Okay, now let's keep breaking this down. So kg, the meters, so meter squared, the second, so we're dividing by second, and divided by second, so second divided by second and second, divided by second and second, divided by second and second, that is second cube, and that is a squared. Now, okay, let's take a look. Do we have any option like this? So kg 2, 2, 2. Here we go. This one. Okay, excellent. Okay, now let's do this one here. So we got circuits here. Let's do this. So we got circuit A. So A is R. So we got R. Oops. So we got R. That is our this, and then the other one is 2R. Okay, so this is connected in parallel to each other, and then we have this is 2R as well. Okay. All right. Cool. Now we know that across this branch, let me use this. Okay, so we know that across this branch, voltage is the same because this is the parallel circuit. Yeah. So therefore, I know that power is equal to V squared over R. So I can use this one because voltage is the same here. Okay. Now let's do this. So we know that power through the first one is 1 watts. So we know this one. Okay. Now, so here, here power is voltage over R. Now what has happened? The R has gone up to 2. The power has gone up to 2. Sorry, the R has gone up to 2. Therefore, the power has gone to go down by what? By 2. So therefore, power. So we know that power for R is 1. So therefore, that power is going to go down by 2. So therefore, it's going to be 0.5 watts. Okay. So we know that's the power in this particular case. Okay. Good. Now, what else do we know? We're using blue. We know that the current that flows through here, let me call this I, let's say I total. So that's current will be split. So some of it will go here. Let me call this I1, and some of it will go here, and we call it I2. Okay, so you learn this in electricity, so the current is going to be split in this particular case, or Kirchhoff, one of the Kirchhoff laws. Okay, now, so let's write this down. So the total current is equal to current 1 plus current 2. Okay, now, what is the equation that links power? What is the equation that links these guys together? Okay, now we also know that current is voltage over resistance. Now, voltage is the same across the parallel circuit. Okay, now if you look at the second branch, so what has happened in the second branch is the resistor in the second branch has gone up by how much? Has gone up by 2. So therefore, this is going to decrease the current by 2 in this particular case. So this tells us that this current here will be less than the other one. Okay, so the current is going to be less than the other one in this particular case. So whatever this current is going to be, so this current is going to be less. Sorry, this current here is going to be less than the other one in this case. So what what can happen? Okay, so what we can say is, since we know that the resistance is twice, when the resistance goes up by 2, the current is going to go down by 2. So therefore, we can say that this current here, I2, is going to be twice as less as the other one. So this gives us a nice equation of 2 I2 is equal to I1. So this makes sense, isn't it? So since the second branch has more resistance, the second branch is going to receive twice less current compared to the other one. Okay, so therefore we have an equation in this particular case here, isn't it? Okay, so therefore what we can say is, we can say that, let me use the blue one again. So we can say that the total current in the circuit is, we know it is I1 plus I2, and this time they're the same, so therefore we know that I1 is 2I2, so 2I2 plus I2, this is 3I2. So therefore the total current flowing in the entire circuit is 3I2. So therefore the current flowing through this one is 3I2. Okay, now we have an expression for the total current is 3I2. So therefore, now what we're going to do is we're going to be looking at this circuit here, sorry, this resistor and this resistor, because their resistances are the same, so they have the same resistance. So what we can do is we can apply this equation in the corner here. So P is equal to I squared R. Now we apply for this equation for these two because they have the same resistance. Okay. Now, so power is proportional to I squared, because this guy here, for both of them, are the same. The resistance is 2R for both of them in this particular case. Yeah. Okay. Now, what are we doing? What is happening here? So IT. So this IT here, this IT. Okay. So this IT is actually 3 times I2. 3 times I2. So 3 times the I2. So actually, what we're doing is we are multiplying this I2 by 3 times. So this, and we know that this is proportional because the resistance is the same. So what we're doing is we are increasing the current by 3, because we want to see if we increase the current by 3, and this gives us the total current, because the total current is in this resistance that we want to know. So therefore, what's going to happen to the power? So if the current's going up by 3, okay, the current's going up by 3, but the current is actually squared, so therefore the power is actually going up by 3 to the square, which is 9. Okay, which is 9 in this particular case. Okay, so let me just do this properly. So as the current is going up by 3, the power is actually going up because current, so if I is equal to 3, so current is 3 times, so 3 times the square is 9, so therefore the power has gone up by 9 times. Now we know that the current in the 2R is how much? 0.5. But this time the current, sorry, the power in this 2R is 0.5. Now the current here, because it's IT, so the current has gone up by 3 times, but since it is current squared, so it actually is actually, so therefore the power has gone up by 9 times. So therefore what we need to do is to get the power here, we need to do 0.5 watts multiplied by 9 times, and this will give me how much is that? This is 4.5 watts. Okay, and then finally, this is our final one, final answer. So the total power, by the circuit, the total power. Okay, I need to fix myself. The total power is going to be 4.5 plus 1 plus 0.5. Okay, so 6 watts. Okay, now this is a very multiple step electricity questions there. You need to know the rules of voltage, you need to remember the equations, you need to know Kirchhoff law, current splits, you need to know the proportionality. If one's going up, the other one's going down. You need to know if you're going up by, if there's a square, you need to square that. Yeah, there's loads of stuff going on in there. Okay, loads of the stuff going on in there. Okay, so I'm gonna go very quickly here. So X, so we have 2 ohms. Okay, now we're going to combine these two together, so these are in series, so these two are in series with each other, so 1 and that is 4 ohms. Okay, and then the total resistance is going to be 1 over 2 plus 1 over 4. Okay, and this is 1 over RT. Okay, okay, and then don't forget to flip it, because you need to do this in your calculator, and then you need to flip it, and then the resistance is 1.3, 3 recurring, and then the Y, you do the same thing, okay, let me waste it. Y, you do the same thing, so you got 1, okay, and this is connected in series, in parallel with the other guys here, so we need to work this one out, so therefore it's going to be, so the one in parallel is going to be, it is going to 1 over 1, 2, plus this one, and then we need to flip this one, so this will give me 1.2, so therefore this is going to be 1.2 ohms. Okay, so therefore the total R is 2.2, and then Z is there, so this is my Z, yeah. This is in parallel, so we add these two guys together. We've got 3 there on the top, and then the bottom we've got 3 as well, and then all these here are connected in series or in parallel. T, so 1 over 3 plus 1 over 3. Okay, so this is 2 over 3. We need to flip this up, so 3 over 2, 1.5, and then you pretty much rank them in order. So from the order of increasing, so therefore which one's increasing? So therefore the first one is the first one, second one is here, and then the third one is here. Okay, so you can actually see that the answer is which one? X, Z, and Y. So X, Z, and Y. Okay, now this one you need to use the equation for potential divider. So potential divider, so you're looking for X, therefore the voltage across X is equal to the voltage, the total voltage, multiplied by the resistor that we're looking for, the resistor in X, divided by the total resistance. So therefore it's going to be voltage is 25, multiplied by the resistance of it is 4k divided by 4k plus 1k. Now the good thing is they are in series, okay, so this will give me volts. Now normally when you slide this, if you slide this, then you will get 0, because okay, that's the minimum you can get, 0, and then if you slide it all the way, you're going to get the maximum voltage. So this is the maximum voltage if you slide it all the way. Okay, if you slide it If you slide all the way down, that's going to be 0. It's going to be 0, so the answer is going to be 0 to 20 in this particular case. Okay. Alright, so 2 more questions and then we're done. 2 more questions and then we're done. 2 more questions, we're done. Alright, so which one is balance? So we need to show balance. So balance. So balance. Okay, what was it? So equilibrium. So equilibrium means there are balance. So equilibrium means there are balance. So balance, so pretty much this equal to 0 resultant force. Okay, so let's do this. 0 resultant force. Okay, I'm just gonna pick one very quickly. I'm gonna pick the first one. Let's go to the first one. Let's see what we got. So 3 and 4. So we got 3 and 4. Okay, so let's find the resultant in this case. The resultant in this case, remember the method, so tip to tail method if you want to do that, or the parallelogram method. So therefore the resultant is going to be, okay, I'm going to use the tip to tail method. Let me use, so this way you guys know. Okay, so tip to tail method, so therefore we have 4 here, and then I'm going to take the 3, I'm going to slide it to here. Okay, so therefore the resultant force, the resultant will be in this direction, so I need to work this out. So therefore x is equal to Pythagoras theorem, you know, the triangle squared, the whole thing squared. So this is 25 squared. So x is 5 Newton. So therefore what I have is I have 5 Newton in this direction, and then remember there's one here which is 5 as well. Okay, so therefore this is 5 as well. So therefore resultant is equal to 5 minus 5, which is 0. So therefore that is the answer straightforward. That is the answer there, A. Okay. Alright, now this one, what do we have? What do we have? We have equilibrium. So it is equilibrium. So therefore, again, so it is balance. Balance equal to no resultant. No resultant. So therefore, okay, so therefore no vector sum at all. So the vectors must not sum up in this particular case. Now you can see that the weight is going down. Okay, you have your tension here. Okay, and then you need to be careful where you're going to put your thing. Okay, so now look at this one here. So the weight is going down. Okay, now P is going this way and T is going this way. So P is pushing this way, so pulling this way, and T is going pulling this way. So therefore, you are going to have a resultant force in this direction. So therefore, it can't be this one. Now this one here, same thing. So T is pulling this way, and P is pulling this way. So therefore, you're going to have a big resultant force in this one. It can't be this one. Now this one, what we have, T is pulling this way. That's the correct one. P is going down, which is good. Now weight is also going down. So therefore, you're going to have a resultant force in this direction, which is not good. Now this one, okay, weight is going down. This one going this way, and then this one going this way. You can see pretty much this is going nowhere. Okay, so pretty much here the sum is cancelling each other out in this particular case. So therefore the answer is A, because there should be no vector sum in this case. So the vector sum should not be adding up to something. So here look, these two add up, you get this one. These two add up, you get the big one. These two add up, you're going to go somewhere. So here it's going to go down, but it's going to go this way. So pretty much this is closed. Okay, so let's say closed up vector. Okay, done. Okay. Alright, so I know it's long, but we need to know the physics, especially you see that the multiple choice one. Okay, so even though the answer is A, B, C, D, and it's worth 1 mark, but there's so much physics going on behind it. And the only way for you guys to get better at the multiple choice is doing the more you do them, the more you're gonna get used to those questions, and the more, so in the future you're gonna be quicker at doing those questions, and it's gonna be stick better. Okay, you see full working out, yeah, full working out. And again, I'll leave the DTs for you to do, and then you can give me the solution for that.